So, my dear student, let us proceed with our discussion here. As we ended by concluding the frequency along to the fog A and also along to the fog B, which respectively to 20 Hz and also 24 Hz. Now, it is a time to look for the stationary waves. Most of our fellow are introducing for us the meaning of them, the term stationary. Now it is time to understand what is the stationary wave. What is the stationary waves? Before we talk about the stationary waves, we should think ourselves. The word stationary, what it means? The word stationary. If you think yourself, my dear student, this words, the things that the word are stationary. Imagine you have what you tried. You are standing in my dear student, don't do anything. Now you are in a station. If you pass any place and you see is that the car is on the parking, then that obey the concept of stationary. It means that it imply it give us the acceleration which is equal to 0. It doesn't move. So any object that remaining that is at rest, it means doesn't move. Give us the meaning of this stationary. So when we talk about this stationary waves, it means that we are talking about the two waves that are in a station. We are talking about the two waves that is at rest. They are not moving, my lovely student. They are steady. This is what we talk here. And sometimes this word stationary is called the standing. Kwa tunapokuwa tunazungumzia stationary wave, it means kwamba ni sawa na kitu tunachokiita ni standing wave, my dear student, as we have been told here. So let us read together the concept here related with the stationary waves. So our concept is say that when two progressive waves, imagine we have the two progressive waves as we tried to explain on the past lectures. So with the same speed and frequency. If we have the two progressive waves and also a progressive waves having the same speed and also the same frequency, and nearby equal frequency, equal amplitude, all of those they are having equal amplitude. After having the same amplitude, the same speed, the same frequency, it must have equal amplitude. So they travel in the opposite direction. They trying to travel in the opposite direction. As superposed on each other, they form a stationary waves. So the concept of the stationary waves, my dear student, we should understood by saying that this stationary waves come from the progressive waves. If we have the two progressive waves and also a progressive waves having the same speed, having the same frequency, and also they have equal amplitude. But this they try to travel in the opposite direction. One of them they are starting from the highest amplitude, and the other they starting at the lowest or the minimum amplitude. So if they travel in the opposite direction, my dear student, and they try to superpose each other, now they produce the term as standing or the stationary waves, as we have been told here, my lovely students. So in the stationary waves, energy is stored in one place. That means the wave do not transfer energy from one to another. So when we talk for this stationary waves, the energy is stored at one place. This means that they do not transfer energy. They do not transfer energy from one place into another place. They could be stored in one place, and they can't not be transmitted from one point into the another point. So in the stationary waves here, the point along the line of the progression with the amplitude is equal to 0 according to the notes. Now imagine we have those two waves, two progressive waves that are moving, that are having the same speed, having the same frequency, and they may have equal amplitude. They try to move they try to travel in the opposite direction, as we have been told on our introduction here. Now the point on which the maximum displacement is 0. This is called on which the amplitude is 0. This is called the nodes, as we have been told, my dear students. Kwa hii point ambayo line ambayo ile point ambayo yule amplitude ni 0 tunaita ni nodes, my dear students. So you could define the node by saying that this is a point whereby then the amplitude is equal to 0, or you could use this mean here that the point, this is the point along the line of the progression with the amplitude equals to 0. Ni concept ambayo unatakiwa uweze kuifahamu kwamba ile point ambayo amplitude ni sawa na 0 tunaita ni node, while the point on which the amplitude is maximum tunaita ni antinode, my lovely student, as we have been told on this statement. So while a point with larger with the largest amplitude is called this antinode. As I told you that, my dear student, the point on which the amplitude is maximum Now this point is called the antinode. As we have been told, my lovely student, the symbol that represents the node is called N, while the symbol that represents the antinode is indicated by the letter A, as we see. So let us jump for the figure number 6 for our topic number 8, that give us the overview of this nodes of this stationary waves, my lovely students. So this is the diagram, the figure that represents the stationary waves, my lovely student, as we seen here. So we have, as we have been told that we should have the two progressive waves. The first progressive waves, we have this one, and also we have the second progressive waves, my dear. So that starting and into the minimum amplitude here, as we observe, my dear, and jump into upward then as we observe here. So on this point, we observe that these are the two progressive waves, but they have equal amplitude. The amplitude of this wave that is formed at the top here is the same with the amplitude of the wave that is formed below here, my lovely students. So after there, we have been told that on the stationary waves we should have the amplitude, we should have the antinodes and also the nodes. So nodes tunaiona kwamba ni point ambao yule amplitude ni sawa na sifuri, while the antinode is the point on which the point on which the amplitude is maximum. Kama tunapoona amplitude yetu inapokuwa ni maximum, ile itakuwa ni nodes, my lovely students. So after there, we have been told that in stationary waves each particle has its own vibration character. Kwa kwenye hii antinode, kwenye hii stationary waves kila particle inakuwa na sifa zake. Kwa kila particle inakuwa na vibration characteristics, as we have been told. So the displacement amplitude of different particles are different. Kwa ile displacement amplitude ya kila particles ni tofauti kama tulivyoelezewa hapa, my dear. So it ranging from 0 to the nodes. Kwa ina range kutoka kwenye 0 mpaka kwenye nodes to the maximum. Kwa ita range kutoka kwenye 0 mpaka kwenye nodes until it reach the maximum, as we have been told. The maximum yetu ambayo ni ile antinode. Kwa itaanza kwenye node itafika mpaka kwenye maximum amplitude ambayo tunaita ni node, my dear students. So after there, all the particle in a given segment vibrate in phase. Kwa particle zote zinakuwa zina vibrate in phase, my lovely student, but in opposite phase relative to the particle in the adjacent segments. So after there, let us try to look an example of this. We have been told the concept here, which is called the transverse, my lovely student. So the particles at the node are permanently at rest. Kwa wale particles kwenye node wanakuwa wako kwenye rest, it means wako kwenye stationary, my dear students. But the other particle attain their position of momentary rest simultaneously. Kwa wale wengine watakuwa wanafika mpaka kwenye maximum, lakini wengine wanakuwa wapo kwenye stationary. So stationary waves can be propagated either in a transverse or in a longitudinal waves. Kwa kuna wale mbili transmitted either kwenye longitude au kwenye transverse waves, my dear students. So An example of this transfer stationary waves, as we have been told, it produces the string of a phenomena. To assume tuna string ambayo ina produce a vibration, as we have been told, my dear. So on the other hand, example of the longitudinal waves is the stationary wave that is produced on the organic pipe. So by saying that, let us stop here. We could come and proceed with the next part. Thank you for following our Educare Media. I wish you all the best.